Let's look at a simple clay jar that perfectly mirrors modern electrical engineering, sitting in a tomb thousands of years before the light bulb. In 1936, railway workers cutting through dirt northeast of Baghdad, Iraq, unearthed a 2,000-year-old burial site from the Parthian era. The Parthians were a major ancient empire that stretched across the Middle East. Among the graves, archaeologists found this terracotta vessel. It's 5 inches tall, and inside sits a hollow cylinder made of rolled copper. Suspended straight down the middle is an iron rod. Capping the assembly is an asphalt plug, ensuring the iron and copper never touch. 2 different metals, separated and insulated. This is the exact textbook architecture of a functional battery, which leaves us with a glaring historical puzzle. No one knows what people were trying to power. 2 millennia ago, this setup creates a galvanic cell, a device generating electricity through a spontaneous chemical reaction. If you pour a common acidic liquid, like vinegar or grape juice, into the jar, the iron oxidizes. That chemical process releases electrons, creating a steady flow of current over to the copper cylinder. This chart tracks the actual electrical potential recorded by modern engineers who built exact replicas of the artifact. You can see the device consistently produces a steady direct current, hovering between half a volt and 2 volts. In 1938, a German archaeologist named Wilhelm Koenig proposed an explanation. He studied ancient silver artifacts from the region, covered in an incredibly thin layer of gold. He hypothesized these batteries were used for electroplating, using electric current to bind metals together. The physical mechanics ruled that out. The heavy asphalt seal on the battery makes it completely impractical to top up the liquid during long use. Even linking several together, the voltage output is far too low to reliably transfer metal. Further chemical analysis has proven that those ancient gold-layered objects were fire-gilded using mercury. No genuine electroplated artifacts from this time period exist in the archaeological record. The battery had to serve a different purpose, one requiring a very low mild current. In 1993, researcher Paul Kieser presented a solution. He pointed out that a weak, continuous electrical charge is exactly what you need for analgesia. Analgesia is a medical treatment designed to relieve localized pain without putting the patient to sleep. We must look at geography. Ancient Mesopotamia was the bustling cosmopolitan center of the Silk Road. It was a massive transit hub, trading materials and ideas with Rome, Greece, India, and China. Western doctors already used electricity for pain relief. First-century Roman physicians treated foot gout by making patients stand barefoot on live torpedo fish. The fish's natural electrical discharge numbed the pain up to the knee. Concurrently, China medicine formalized acupuncture, using needles at specific points on the body to treat ailments. That knowledge was actively moving westward along those same trade routes. The physical link sits in the ruins of Seleucia, a city just a few miles from where the first battery was dug up. Excavating similar battery jars there, archaeologists found them buried alongside thin bronze and iron needles. Mesopotamian healers likely put these 2 concepts together. By attaching those conductive needles to their homemade battery, they delivered a mild numbing electrical charge into inflamed tissue to trigger the body's natural painkillers. Ancient physicians successfully merged Eastern medical geography with Western biological observation. They built their own localized power source and performed electroacupuncture 2 millennia before modern clinics adopted the exact same therapy. Alessandro Volta is credited with inventing the battery in 1800. His true achievement was mapping the theoretical physics behind electrochemistry, allowing the world to scale it into the power grids we have today. The ancient craftsmen didn't have the physics equations, they simply knew how to manipulate the materials to get a result. Modern forensic science could confirm this medical theory in a matter of weeks. We could use X-ray spectrometry, a technique that identifies the exact elemental makeup of a material, to check the copper for trace deposits, and use organic residue analysis to determine exactly what acidic liquid they poured inside. But we cannot run those tests. In April 2003, during the invasion of Iraq, the National Museum of Iraq in Baghdad was heavily looted. The original Baghdad Battery was stolen. The artifact vanished into the black market. The physical object required to run direct microscopic analysis on the iron rod's corrosion patterns is permanently gone. The disappearance of this object forces us to look at how fragile human progress is. Someone figured out how to generate electricity in the desert, refined it to heal their patients, and then the knowledge died with them, waiting thousands of years to be found and lost all over again.